Okay, so good afternoon to everybody. I hope that we are all doing fine. I'm doing fine. I hope the same goes to every single one of you. Today, we're gonna carry on with the topic from our last class. Just recap, we had started and we went quite far with test-driven development. Today, in our first half of the class, we will wrap things up. I will demonstrate some of the other features that still needs to be discussed about test-driven development. We need to add 2 additional methods, test methods to our project. Okay, so we're gonna be doing that during our first half, and during our second half we will be going through an exercise. Okay, so we're gonna have time for an exercise. You will do the exercise on your own. I'll be here to assist you. Very important that you take the time to do this exercise. It's just about 50 minutes that you're gonna allocate for that, and I'll be able to assist you as best as I can within the setup that we have right now. Okay, so as usual, I have Padlet open. I'm gonna open Slack as well in case we have some conversations there. So to get us started, let me open the project from yesterday's, not yesterday, sorry, from Monday. So we stopped then right at the point that we had done the first test method. Okay, so just to recap, we have this application, which is a very simple calculator, and we are creating a few tests to make sure that the divide method is working fine. Okay, we have created one already, which tests the best situation here, the best case scenario. Everything, we have correct numbers, we have an expected results. Then, just to recap, you can open the Test Explorer in Visual Studio by going to Test Explorer, and if it opens in a new window, you can move it up here. Let me see if I can. Let me try to make this in your. Okay, perfect. So we have it here. So we have this tree view that displays the tests. We have just one for now. It's a green checkbox because the test is working fine. I can click on the run button, it runs the test, and you're gonna develop 2 more tests. Before I get going, are there any questions from anyone so far based on last class? A few, perfect, thank you, Martin. A few notes here. Next week on our second class, so next Thursday, I'll just get to the question in a second. So next Thursday, we're gonna have our quiz number 5. That's the last quiz. Okay, so the topics of that quiz will be graphical user interface, that's the first one, and test-driven development. This is the topic that we're covering from last class in this class. So again, 2 topics for our next and final quiz next week on Thursday. Mustafa, is this topic covered in the textbooks? No, it's not. This topic is not in the textbook. This topic, you're gonna find reading material in the links that I have provided on Centennial under week 12. Okay, so this topic is not covered in the book, and you're gonna find the links there that will address more material there. Okay, so Martin, yes, quiz 5, graphical user and test-driven development. Yes, perfect, thank you, I appreciate that. Awesome. Okay, so So, what's the next step here? Let's carry on with a new test. We're going to develop a new test here. We are going to, let me ask you this. What will happen if you look at the divide method? What will happen if I send denominator as 0? What will happen there? Anyone? Perfect. So an exception will be generated. Yes, a division by 0 exception. Okay? Thank you, Mustafa. So can you say, listen to the statements and see if you can agree with me. Can you say that I expect an exception to happen if I give a 0? Is that correct? A correct statement? Okay, assuming that this is correct, the question is, can I create a test that tells me whether or not an exception has been raised if I give a 0? Can I create that test? The answer is yes. We can create that test. So tests that we create, they not only can check for return values, but they can also check whether an exception has happened or not. And as you can see, there might be a code scenario that I may expect an exception. Remember when we were talking about exceptions and I mentioned to you that sometimes whoever is throwing the exception is not necessarily the one catching the exception. So my point is this: if I send a 0 as a denominator, could I have used a try block statement to handle it here? I could, but I would rather have whoever is calling the divide catching that exception. So to be honest, in our form code here, we could have a try catch statement that would catch any problems, any errors with the divide method. However, and that would be fine. So we could put a try catch right here. But what we're trying to do today is just a continuation of our testing situations, testing scenarios. So we have tested a very simple one, which we compare an expected value to an actual value. Now let's create another test, another unit test that will verify whether or not, given a denominator equals to 0, are we gonna really get an exception? This is what we're gonna do now, okay? Yes, color 006, expected exception there. So let's create another test method, and we're gonna call this one public void. Test methods, they need to be public, need to be void, and third one, come on, anyone there? Public, void, what is the other requirement? The third and last one for a test method. No arguments, no parameters, yes, that's the one. Thank you, Mustafa, thank you, Shaima. Okay, so now let's think about, because here's what we're gonna try. We're gonna expect an exception here. So just to reconnect, how do we name methods, test methods? Well, first part is the name of the method. Second part, it's the inputs that we're gonna give to this method. Let's think about this. What do you know about the inputs that you're gonna give to our divide? In this case here, what is it that you know? Remember, what are we gonna test? Remember that to test that, what are some of the arguments that I have to pass over to divide? That's true, Mustafa. So we're gonna have a divide by zero exception here. Exception is the result. So let's think for a second, what is it that we are giving? Actually, what we're giving is, we're giving zero denominator. So I can call it like this, zero denominator. So that's the argument that I'm giving. Again, this is flexible, okay? I'm just giving here an example. And the third one, the third part of our name is the expected result. Well, we expect a division by zero exception. But I don't need to put the whole thing there. I can just say something like, I'm expecting an exception. Okay? So here, but just by looking at the name, I say, okay, this is the name of the method. This is the type of parameter that I'm going to send in. And this is what I expect to happen as a result of the call. Okay? So we're going to use our three sections here again. Numerator, it doesn't matter too much. Okay, I can keep 20. Denominator is a 0. Okay? Because that's what we're testing. We're testing if this will trigger an exception or not. Okay, so I'm going to say denominator equals to 0. Expected. Now, here is where this new method is different from the original one, from the first one. Is that, we don't have an expected result. We don't have an expected value back. We have an exception. Exception is not a return type. It's not a return, okay? So I'm not expecting any value back, okay? Now, I'm going to call simple calculator. I'm going to call divide. I'm going to send both arguments here, okay? Now, with this call, again, what will happen here? What is going to happen when I call divide here? Okay, when I call divide, it's going to do what? What is it? Throw an exception. Yeah, that's right. So, because the assert will be a little bit different as well, because we don't have a value back from the call, back from that, actually, there will be no return value, because it's gonna trigger an exception before it returns anything. Now, it's gonna trigger an exception here. So, in our assert section, we're gonna have this empty. We're gonna have this, it has nothing here in our assert. But we're gonna create another annotation in our method saying that this method is expected to result in an exception. So we can add an annotation here that says expected exception. And we can say, what is the expected exception? Well, it has an argument here, and I'm going to use the method called type of. So we're going to have to return the type of the exception that it's going to be thrown. The exception that's going to be thrown is the divide by zero exception. So with this line, I'm telling that this method is expecting this exception. That's really it. That's how that's how a test method that expects an exception looks like. We don't have anything in the assert, but in the expected exception, we annotate this method as expecting a divide by zero exception. Okay? How about we give this a try? We give it a run here. Okay, so I'm going to click there. As you can see, there is one method that has not run yet. I'm going to right click on it, run. And then, look, we have a division by 0 here. So let me run everything again. Okay, perfect. So look, divide by 0 exception worked fine. Okay? So look, it might be a little bit confusing, but we can have test methods testing whether or not the methods, the call, generated an exception. This is one of the cases. Okay? Let's do. Actually, let me just give a second. Any questions about what I just mentioned? This example. Okay? Okay, so moving forward here, look. If I go back to the methods, what if I say this? What if I put an if statement here? If I say something like this: if denominator equals to 0, return 0. Else, return the division. After this change, are we still gonna have an exception if I send denominator equals to 0? Think about that for a second. Am I gonna still get an exception when I call divide and I send division denominator with 0? No, we will not. Okay? We will not, Mustafa, because if denominator is here, 0, I test if it's 0 and it returns a 0. Okay? So the division will not happen if denominator is 0. Okay? So guess what will happen with our new test methods? Will it succeed or not? Will it work? Will it fail? Or will it succeed? That's fine. Color 6. If it won't catch the exception. Actually, it will not catch the exception because it's not going to throw an exception. Okay, so let's run the test again. I'm going to rerun. Look, divide 0 denominator failed. Failed because, look, tests did not throw expected exception. Divide by 0 exception. It didn't throw. It didn't throw anymore. So even though we no longer have an exception here, but our test was testing whether or not, our test was expecting an exception. It didn't throw. It didn't throw. Because of that, the test has failed. Okay? Might be a little bit complicated because we may think, okay, it didn't return an exception and the test failed? Yeah, because the test, again, is expecting a divide by 0 exception. And it's no longer throwing. Okay? So, as I said, we can not just check values, but we can check if the methods return, if the methods trigger an exception as well. Let's revert this. Let's go back there. Let's comment this out. And then let's give it a try again. Let's recompile. Let's retest this. And let's see. Awesome. All good now. Okay. Any questions? We have 30 people in class. It's a great turnout. Great turnout, really. So, I don't believe that all 30 of you understood this 100%. I hope so, but it's a tough one. Anyway, we will have a chance to practice that in a few minutes with an exercise, okay? Great. Okay, so I'm gonna remove this part here. Okay. Question here, Mustafa. Could it be considered we are testing the exception handling itself? We are not testing the exception handling, Mustafa, because what is exception handling? Exception handling is when you use a try catch block. Okay. Now, I have to admit that if we have a try catch block that is gonna try to catch a divide by zero exception, this test is very fine. It's not handling, but it's verifying whether or not that divide by zero might be happening. It will verify that. But this is not testing the exception handling itself. It's not, because exception handling is, I'm going to give an example here. I'm going to go to the form and I'm going to put this thing right here. I'm going to say try this catch divide by zero exception. I'm going to call it error, and I'm going to say message box show, and I'm going to say error dot message. Now this, and let me just declare, I would have to declare int outside, and I'll have to say result here, because otherwise int result would be only available right here. And I think that I have to initialize it as well. So let's initialize it, that's fine. So we call it here. This, Mustafa, this exception handling, this is exception handling. We are catching if there is an error. Actually, if there is this error here, and I can demonstrate that. I'm going to run the application. If I put a 0 here, if I divide, it's good. But if I put 0 here, divide, see, we don't get a broken application, but we get a message, attempted to divide by 0. Okay, so again, this is how can I say, an exception handling. However, the test itself is not. Does it make sense? But it is very fine that an exception can happen there. That's really it. Okay, if you have a follow-up question, let me know. From Yonga, okay, if we test the methods with try-catch statements, the test will be false. That it will. You know, so if we do a try-catch right here, so if we do something like this, try, and I'm just gonna put a generic catch here. I'm just gonna say return 0. So here's the thing, Yonga. If we do this, the divide method is handling the exception itself. It's not throwing back to anyone. So we're gonna try that. If I run the test again, the test will fail because divide took care of handling the exception itself. So let's give it a try. So let me run the test here. Look, 0 denominator failed because it didn't return an exception. It throws internally, but it handled the exception. It never throw out for anyone to catch. It's like it thrown and it caught the exception. Okay? Make sense? Joanna, can you please post the code for simple calculator test on Padlet, please? The code is already available, Joanna, on eCentennial. So if you go to eCentennial content and you go to week 12, here's the code, calculator example Windows, okay? So it's already there. Not including the simple calculator tests? Are you saying that it's not including that there? I downloaded this just yesterday and it was. Have a look again, Joanna, because I mean, I'm gonna download it quickly here. Make sure that you open the solution, not the, don't open just the project, open the solution. Look, I just downloaded. Here is actually, here's the one, because I've done that before. Yesterday another student asked kind of the same question, and here's the test, calculator test. Look, it's all there. Make sure that you open the solution file, okay? Give it a try, and if you still have problems, let me know during the exercise, okay? Awesome. Okay. So I saw a question on Padlet. When is the final test and how we gonna do it? Can you please elaborate? Okay. Final test is in 2 weeks. So on April 16th is our final test. On April 13th is a Monday, and on that Monday I'll be doing an exercise that will get you ready for the test. The test will be very similar to midterm. How did we do midterm? We have a hands-on test that you had 1 hour and 45 minutes. You have an exercise to execute, to code. Once you are done, zip up the code, upload to eCentennial, you are done. The topics for the final exam are 4 topics. We have 1, graphical user interface, GUI. 2, it's the bundle of inheritance, polymorphism, abstract classes, and interfaces. 3, it's test-driven development, this topic here. Okay, and 4, we're gonna have a little bit of exception handling. You're just gonna have to implement a little try catch block, but it's a very simple one. So that's about it. That's the final test. If you have a follow-up about the final test, let me know. Let me see here. So what is the point of using tests if we are handling exceptions? Okay, good question. Shaima, good question there. Okay, so let me tell you this. One of the jobs of testing is exception. You're gonna verify if you are getting exceptions. That's fine. However, look at our first test. It has nothing to do with exception here. We are testing whether the expected result, which is true, is if it matches the actual results. See, testing is mostly about getting to know if the logic that you have implemented is correct. One of the side effects of logic are potential exceptions, but by far it's not the only one. We may have different a math that was done wrong. Like for instance, let's get rid of the try, of our try catch. Let's keep just as it was before. Now, actually, let me keep the try catch here. But look, if we make a mistake, here in the sign, look, if I put a plus here instead of a divide, look what will happen with this test if I run it again. See, it failed. The test failed because the result is not coming up as we expected. Look what it says here. Expected 2, but actual 30. This has nothing to do with exception handling, okay? So, let me see here. So again, Shema, let me know if this makes sense or not, okay? Let me know. Okay, perfect. Mustafa, let me see. Are we going to keep GoToMeeting running as we write the test? I'm not sure, to be honest. I haven't thought so far about that. My thinking about that now, I think that we will. Because you may have questions, and how will I be able to assist if anyone has a question? Okay? You can ask me questions in the chat. I can answer privately, I can answer publicly. I may not keep my voice going on unless I need to say something to everybody, so I may mute myself here. But yeah, because otherwise, how can you communicate if you have questions about the test? Because you're gonna have a limited amount of time, you know. No, but we're gonna be doing like what we're doing right now, Mustafa. I'm not gonna be looking at you or monitoring your screen there. Okay, I'm not gonna do that. Okay, if that's what you are asking about, because nothing will change as compared to what we're doing right now. I don't know, did I get you wrong, or does that make sense, Mustafa? Again, I'm gonna give you the test, you're gonna do it, and you're gonna upload. I will not be looking at your screen and what you're doing there. I'm not gonna do that. If that's your point, Mustafa. Anyway, I have another question here. So yes. So I'm not gonna say your name because you told me that you sent me this in private. But maybe I'm gonna ask if I can share program final. Yes. Someone wrote the topics here. This is it. GUI, inheritance, polymorphism, abstract classes and interface, test-driven development, which is this one, and exception handling. If you want to share, okay, perfect. So thanks so much. These are the topics. Actually, let me just write that down. Okay, just in a different way. These are the topics, and I'll put that on Padlet as well. Okay, perfect. Okay, so I'm gonna return this back to its original state. We still have one more test to write. As we come back to the original point here, let's make a proper division. Let's run everything again. Okay, so let's go to our, MD Hilal, do we have review class? Yes. You can consider the second last class as our review because that's the exercise class, okay? Remember that the class right before the test, we're gonna do an exercise that will be helpful for the test, okay? And during that exercise, as I go through the solution, you're gonna get your review. Does that make sense? Awesome. But do this. Do the exercises as well. You have good exercise there to practice this stuff. Okay, so do that. Anyway, last one here. Last method, last test method. Okay. Look, I know our divide is very simple, but I want to apply a business rule to this divide. I want to throw an exception during the divide if the denominator, which is the lower one, if denominator is greater than numerator, I want to throw an exception. I don't want to accept any divisions where the denominator is greater than the numerator. You may ask, Ederson, why are you applying this crazy rule? Well, because in my special divide method, this is the rule. I'm just gonna give you an example where I'm throwing my own exception that I have created, and we have to test this exception as well. Okay? So I'm gonna call this like this. I'm gonna say something like this. If numerator is less than denominator, throw a new exception. And I'm gonna give it a message here, okay? So I'm gonna say denominator cannot be greater than the numerator, okay? Again, I'm just establishing this rule here, and I'm gonna throw an exception if this happens. Remember when we saw exception handling, I had you to picture that whoever throws the ball throws that to somebody else to catch. Okay, so whoever calls divides should be the one catching that. But right now, we are not catching exceptions here. We are just testing. We are testing if those exceptions are really working. That's what we are doing here. Okay, so if I go back to our simple calculator, we're gonna create a third test method. So we're going to create this method here. So test method. I'm going to call it actually public void divide is the name of the method. So here's what we have. Any suggestions on how should I call this second part of my method name, on my test method name? Any recommendations? What we want to test is it gonna throw this exception? So my name there should somehow represent the fact that the denominator is greater than the numerator. Okay? That could be, Mustafa, numerator less than. It could be. Could be. Awesome. I like that. We could do numerator less than. That's great. Awesome. It really describes that. You can name this many different ways. You can do denominator greater than. You know, it doesn't matter. What matters is that as long as you can describe this well, that's what we're looking for. And then the last part, what is it that we expect? Well, we expect another exception. So here we go. This is our test method. Okay? We're gonna have it very similar to the previous one. Now, we're gonna have the numerator has to be smaller than the denominator. So we can say, I don't know, we can say something like this, okay? 20 for numerator, denominator is 40. So again, denominator becomes greater than numerator. So we are matching this condition here, or this statement there. Numerator is less than, okay? Now, I know that there is an error that will return here. So I can just call simple calculator.divide and see what happens, okay? Now, are we missing, let's compare this to the previous test method. Are we missing something here in our new test method? Exactly, color 006. You're right, we are missing this line. So I'm gonna say expected exception. And now what is the exception that I'm expecting? It's just exception, okay? Because look, we are throwing just a simple exception with a message, okay? Okay. Now what? Now what? Come on, what should I do now? I should run the test, okay? I should just right click in my tests, run all of them, and let's see how they go. All green, okay? All 3 tests passed, okay? As easy as that. Again, I'm gonna give you a second. Any questions here about these tests? I'm checking Padlet, there's nothing there. Okay, Clara, what about assert? Did you write anything there? No, I did not. I didn't because, in a way, this is a special type of test, because assert, we use this area when we are expecting results back. In this case, actually in both cases here, on our last 2 tests, we don't expect values back. We expect exceptions to be triggered. So if an exception is triggered during a method call, the method doesn't return any values, okay? So that's why our assert is empty. There is nothing in our assert, okay? Awesome. Okay. George, okay. Can we get many different expected results in the same method? Not advisable, George, because not advisable. And I'll tell you why. Remember, this is called unit test. So a unit test is testing a unit of code. If you are trying to test more than one thing, think about this. It's no longer a unit. If you are testing more than one thing, what you should do for each different test, what is it that you should do? Tell me. If you are expecting to have many return values, for each one of the expected, you should break it down into its own unit test, its own method. One unit test is for one single scenario. Don't mix it up. Don't put many things in the same scenario. It's for one and only one scenario. Now, you can have, I don't know, 20 scenarios, but create 20 test methods. Don't do that in all in one, because otherwise, what should be a unit, now it's really multiple units in the same method, and it breaks the pattern here. It breaks the approach that we are taking with unit tests, okay? Like different cases. Yes, George. like you have one method here that tests. See, look, we have three methods here, three test methods. This is one scenario, this is another one, and this is a third one. If you have more, keep adding, nothing wrong with that, okay? Awesome. Okay, can we check if assert is true with the exception as a parameter? No, we cannot, color 6. Assert is true is to check if the arguments, if whatever is being sent to it is false or not. Again, the way to handle exception, this is the best way that I have demonstrated for you. Okay, Clara, can I use a for and assign different numerators and denominators in the same test method? Okay, very, in a way, similar to what George has asked there. So, can we use one single test to try multiple things? You could, but then you are breaking the unit here. Because this is what I would like you to have in mind. Unit tests, each method is a unit. It's a unique situation. If you are testing in a loop more than one value, each value that you are giving is a different test. Okay? So, a test unit is for one and only one single test. Okay? I see what you're trying to do here, but for that, you're better off to break it down. Now, are you gonna, let's say, are you gonna create 100 tests because you want to test with 1, 2, 3, 4, 5, 6? Now, you have to be reasonable, okay? Most likely in your planning, if it's gonna work for 2, it's gonna work for 3. Unless you know that there's a rule inside that should do something different. If it's a 3 or a 2 or a 1. But I can tell you this, if it's gonna do something different depending on the number, you should have a test case for each one of those different scenarios. Okay? But I'm just gonna address that, Clara. So, just because your method is expecting integers, you're not gonna try with every single integer out there. You're gonna try within a scope that makes sense to your situation. Okay, like I'm gonna give here 2 numbers. We have to look at our potential test case and maybe look at edge cases. Let's see what will happen if I give very, very, very huge integer numbers. Will it still work? Maybe create a case for that. But again, you don't necessarily need to create a case for each and every little variation of your numbers, if that's kind of what you are asking there. You know, okay, so yeah, I don't know if it makes sense, but let me know. Okay, Mustafa, so a unit should be a single exception or operation? Correct, yes, it's a single operation, it's a single test. Let's put it this way, it's a single check. It's one and only one thing. This is a very unique situation, okay? That's correct, you can call it like that. Okay, great. So there is still one last topic here. Actually, two little things that I want to mention before we move to the exercise. Okay, Clara, what's the big advantage of using unit tests instead of try-catch? Okay, so very similar to what Shima has asked. Try-catch is one scenario. Sorry, let me rephrase that. Exception handling and throwing exceptions is one case of output. In this case here, for example, this test scenario, the first one, has no exceptions there. So it's not that one is better than the other. It's not like that, okay? It's that they serve different purpose. The test here is you writing code to check if your code is working the way you expect. Oh, if I give a 20 and 10, I expect 2 back. Is it working? Yes or no? This will test. Oh, if I give a 20 and 0, this should give me an exception. Is an exception being given? Yes or no? This is what this method is checking. Last one. If I have a numerator which is smaller than the denominator, will it give me an exception? This code is checking that. It's checking if it's giving the output that you are expecting. That's about it. This test here has nothing, it doesn't go live together with the codes. This is a separate piece of software, okay? A separate piece that is used just while we are developing the application to test if it's working the way it was planned to work. That's what this is. Again, it's not that it use one or use tests or use tries. It's not like that. They are not a replacement of each other, okay? Try and catch is used inside your application. Test is like, I have a test application here, I'm gonna test this application. Try catch is inside the application. The test application is outside here, and it's accessing the application right here, but it's not part of it. Don't know if that makes sense, Clara. Let me know there. That's a good point, Clara. Yes. As I think that, I don't know if I mentioned that, but the test application is like you're creating a little robot that will call your application, and it's testing it. It's testing the application. It's like your little robot, okay? Awesome. Okay, George here. Is this the only kind of testing we can do with C#, or just unit test is covering this program? Okay, so only unit test is covering this program, and only using MS Test. MS Test is the framework, the test framework that comes by default with C#, Visual Studio from Microsoft, okay? There are other unit test frameworks that can be used with C#, but they are add-ons. They have to be added separately, okay? And that's the only one that you're gonna be studying in this course. Mustafa, are unit tests also used to find exceptions which are then subsequently coded? Let's think about this. It can be. Now I can tell you this. Let's say in our first case here, what if this scenario triggered an exception? It would catch that and it would fail the test. And now I would say, oh, okay, so if I give 20 and 10, it's causing an exception. Let me address that. Let me see why is that. Then you go back to your code, because remember, if in our first test, if this is causing an exception, the test will fail. And then you're gonna look, oh, why the test failed? Oh, because it gave an exception. So let's see what's the problem here. Okay, so as you're putting, it would help as well to identify exceptions. Yes, it does. Okay. Brandon, does the values for numerator and denominator have to be hard-coded? Yes, they have. They have, Brandon. Because here's the thing. As I was just describing to Clara, think about these numbers here. As the little robot, I'm gonna tell my little robot what are the numbers that it has to input. Here, take 20, take 10, put them there. Put them there and see what happens. Okay, so we have to know those, because otherwise, how can we know the expected result? We don't. So, and also, if you are thinking that we could ask the user to enter those, the whole idea of having unit tests is not needing to have a user testing the system manually. Because, look, I can always run this application and I can put a 10, a 20, and a 10, and I can see the results. I can visually verify that. But what we are doing here is we are doing code that will test that for us, so we don't have to manually test it. Okay? Hope this makes sense. Okay, okay. Great questions. Great question. I love the questions. Okay. There are 2 more topics that we're going to be covering, but let's give it a break. Let's take 5 minutes. Once we get back, we're going to finish those two little topics. We're going to do another quiz just to test us a little bit here, and then we're going to jump to the exercise. So again, 5 minutes. We'll be back with final 2 points about this topic. 5 minutes. Okay, okay. Can you please just give me some feedback here? Let me know if you can hear me, please. Just give me a quick yes. Thank you, Shima. Thank you. Awesome. Good, good. Okay, so last topic here. Last 2 points. As you can see, think about this. We have just one very simple method here. And just out of this method, we have 3 test cases here. 3, okay? So you may find that in a larger system, you may have dozens, even hundreds of tests, okay? So imagine that it might become a little bit messy to organize those methods, okay? So Visual Studio has a way that we can classify methods. We can put labels, we can flag methods. We can say, hey, these methods belong to this department or this user. The other methods, these are I mean test methods, okay? The other methods might be important. These are not so relevant. These are very important methods, okay? So we're gonna see right now how we can apply classification to the methods so we can organize them better. We're gonna start by using another annotation called owner. So we have an annotation called owner, and we give the name of the owner. Now, you can think about this as a person or maybe as a department, okay? It could be like that. I could say that this is accounting. And this other method here, this test method is sales. And this is from sales as well, okay? So I can divide like that. once I do that, what I can do is I can save. And if I rerun the tests, look, I can now see this column called traits, and I can filter this column. I can say, okay, I only want to see the sales tests or the accounting tests. Okay? So it is just a way to classify, to filter them, to organize them. Okay? That's one. And we have another one. So we have owner, which you can give a name. And we have test category, which is also a name too. And I can say that this first test is important, but the second one is actually very important. And the last one is important as well. So we can create actually, or not important, or less important. Okay? If I run the test again, now look at the traits. I have the owner, and I have less important, very important, important. I can filter by all of them. I only want to see, let's say, the very important ones. Okay, so this gives me the necessary filtering, gives me filtering capabilities. I want to see the very important and the important ones. So it filters that. Okay, so those two annotations, they are used to classify the methods, to organize them better, so you are able to manage them better here. Okay? Awesome. Any questions about this? Okay. Oh, actually, I saw a question there in the break. Let me go to that. So, where can I find the last class recording? As usual, as I have told, since the very first class, all the recordings can be found under content, under videos, and you can go to our section. Our section is section 003. You can find all recordings since the very first one, including the face-to-face and online classes, right from the playlist. You can just click here in this icon and then scroll all the way down. You're gonna see the one from Monday. Look, the one from Monday is right here. The ones from last week, they are here. Okay? So it can be found under eCentennial, content, videos, and find your section. I hope that answers the question. Any other questions? Anything else that you may have to ask about tests? Because that's about it. That is about it. I have one last Nearpod that I would like to do to wrap things up, and then we move to an exercise, to a hands-on exercise. Okay? Okay, so if you can please open Nearpod. So go there to Nearpod. Here's the code, and I'm gonna also paste a link in the GoToMeeting chat, okay? So take a few minutes. Here is the code. The link is on the chat, and I'm adding it to Padlet as well. Give it a try. It's just to wrap things up. For questions, I'll give you guys 2.5 minutes here. And if you miss our exercise songs, well, we just have 2 minutes. No. Okay, let's have a look at that. So how did we do here? Okay, so a few incorrect. It's okay, as long as we get to know what's going on. So here we have 4 questions. So first one here. If a test fails, it means that your code has a compilation error. Is this statement true or false? It's false, because if a test fails, it fails. The failure there, it's not a compilation problem. It's a logic problem, okay? Awesome. How do you decorate? And by the way, when I say annotate in the method, it also, the other term that is commonly used is decorate. So how do you decorate a test class and a test method respectively? B, so we don't have validate class, category class, tested class. No, we have B, test class and test method, okay? So that's the second one. Okay, check all valid examples of available decorations for test methods. All of them look good, look okay. All of them look good. Yeah, so you have test method to define whether a method is for testing or not. Expected exception, owner, we just saw that. And the last one, test category, we also saw that we can create different categories with different owners. Okay. Okay, the assert class has a collection of helper methods, static methods, to test various conditions within unit tests. If the condition being tested is not met, an exception is thrown. All methods below are available from the assert class, except which one? False is null. D. Okay. For us to check that, we can just go to the code, put a dot in the assert, and have a look. But we have are equal and is false. We have are not equal and are same. We have fail and is null as well. But we don't have is truthful nor is not nullable. We don't have this. Okay? So that's that one. Okay? Again, in a question like that, you can just check the code a little bit there and have a look. Okay? Awesome, awesome. Thanks so much. Any questions? Any questions before we get our exercise going? So, during exercise time, initially I'm gonna take a quick attendance. So don't drop yet if you're planning to drop. Don't drop yet. If you decide to drop it, but do the exercise. Take the time to do the exercise, okay? So I'm gonna take the time. If you have questions during the exercise, let me know. If you want to address anything about, I don't know, the assignment or anything like that, let me know as well. The exercise is available under week 12. If you go to programming exercise 14, if you go there, you're gonna be asked to put together a bank class with various methods. Sorry, with various properties and a few methods here, and you're gonna be asked to develop this little interface here, and you're gonna find some tips about the code that you should be using, and you're gonna be writing a bank app tests, which you're gonna be creating 2 plus 3, so you're gonna be creating 5 test methods in total. The names of the methods are given, you just have to implement them. It's an exercise that will take you about an hour to get it done, or even a little bit more. The idea is to start now, take this back to your own time at home, and then come back to me next class with questions. I want to see questions about this. Okay? Perfect. Okay. So you can get it going. I will be providing the solution for this exercise on Saturday or Monday. Okay? But keep pushing it. Keep it going. I'll take a quick attendance right now. My pleasure, Mary Christine. Okay, so I'll just take a quick attendance here. So I'll check, I'll call your name, and I'm checking the list as well. So most of you, I'll see it here. I'll see you here. So Ahmed Ali, I see your name. If I call your name, maybe just give me a heads up there. Yep. So Ahmed, Aslan, I see you as well. Amin, I see you. Brandon, I see you as well. Carl, I see you. Caller 006, you may want to add your name to the chat because I don't know who you are. Saima, did you give any code that will help solve this exercise? Yes, I gave the code just now. Saima, the one that I just gave it now. It's under week 12. If you have a look there, calculator example window. Okay? This is the one. We just went through the entire code. No problem. Okay, so Clara, I see Clara there as well. I don't see Dhruv. Gurneet, I see you there. Ila Song, Ila, I don't see you there. Ila. Jasmine, I see Jasmine there. Jennifer, I see you. Joanna, I see you. George, I see you. Joshua, I see you there as well. Karina, I see you too. Martin, I see you. Mary Christine, MD Hilal, Mustafa, Nita, I see you too. Nihal Kumar, Nihal Patel, yeah. Pawan Preet, yeah, you're there too. Saima, Sagar Kumar, yep. Shaminda, I don't see you. Okay. Shima, I see you as well. Simran, I see you too. Sayed, I see you as well. Tanvi is there. Teresa as well. Tomoy, I think I saw you. Tomoy, I think I saw you earlier today. Maybe you dropped. Tomoy, I don't see you. Okay, thank you. Great. Okay, so Tomoy, I don't see you there. Okay, so Tony Lin. Tony, let me see if I see you there as well. Yonga too, and Yusuf as well. Perfect. So everybody, I think that I put the correct ones. Great. Okay, awesome. Thank you, Teresa. So again, you can carry on with the exercise, and I'll be hanging around here, giving you a hand, giving some assistance here as you need. I have Slack open as well in case you want to send me a screenshot or any piece of code. I have Slack open too. Okay, Karina. Okay, you can ask. Good point, Karina. I fixed that one. Okay, so use the constructor that has the color. Okay, it's not the one that has a string. Okay, I think that I know exactly what you were talking about. You got my point? Yep, that's it. So yes, I saw that little mistake there. Okay. Okay. Let me see here. Okay, just to let you know, Mary Christina, I'm looking at the screen that you sent me, okay? Mary Christine, try this. Try to copy the codes to the local environment, because I'm assuming that you are using the VM, correct? Is that VM machine that you are using? Yeah, I get it. Okay. Uh, yeah, I get it, but there is, because you, from the message that it's showing in the outputs, it's output into the H drive. So you may want to copy this code. You may want to copy this code to the the main drive. Also, I think I saw another student. Yes, I think I saw another student with a similar issue. Try to do this, because maybe the version that I have provided, it has newer libraries than this one, because this is Visual Studio 2017. Okay, so actually I'm gonna give this a try as well. I'm gonna do the same thing that you did. I'm gonna open the VM, and I'm gonna give this a try there and see what I get. Okay, give me a few minutes. I'm gonna give this a try. Mary Christine, do you have the link to the app's login? Because I don't have that on top of my head, and last time that I tried to find, I didn't find it very easily. Do you have it available easily there? That has the login to be able to call the apps, whatever that is available. Do you have that link? Okay, perfect. So thank you for that. Let me give this a try. I get it. Yeah, it's the you have to use the network credentials. Yep. And then, Mary Christine, do you select the Autodesk 2017? Is that the one? Okay. Yeah, Karina, you can post that on Slack, okay? But as long as you're talking about assignment 4, I assume, as long as it's output in the same image of that little guy with the hat, should be fine. But yeah, you can post it there. I can have a check. Oh, it's working now, Mary Christine? Is it? Awesome. Awesome. Good to know. Very good to know. Okay, so you saved me the trip to the VMware. At least I saved the location of the URL. Karina, it looks good. If that's the one that you send on Padlet, looks good. Mary Christine, how many items will be the quiz 5? Quiz 5 will be a 9 or 10 questions, okay? Between 9 and 10 questions. Okay. That is correct. Yes, Karina, that is correct. If I don't think that, because I've provided the codes that you have to put in the main. If it's not in that code that you have to put in the main, you don't have to. No problem, no problem. My pleasure. If you want to mute, you can mute, okay? Okay, so how are we doing with the exercise? No questions? Everything going smoothly? You have until next class to have a look at that. Monday is our next one. Before you leave for the day, just want to wish you a good rest of the day, good rest of the week, good weekend. Take care of yourselves, and I'll see you, all of you, on Monday. I'll still be around if you need me, but thanks so much, okay? Thank you, and I'll see you next Monday.